Okay, Wildcats. Today we're looking at Monday, April 2nd, solving exponential and logarithmic equations, part 2, on page 69. If you would, update your table of contents. Now, because this is part 2, there's not going to be any notes. We're going to go straight into the examples. All right. Now, a couple things before we get started is I think it says day 2, but let's change it to part 2. And if you have whiteout, that'd be great. If not, you can kind of mark out some of this information and move example 2 up here so that you have space to work it. Okay. All right. So now with that, let's look at example 1. All right. Solve the equation and check. So to solve this, we see that the bases are the same, so we know the exponents are equal. So we have x squared equals 16. Okay. Take the square root of both sides, you get x equals plus or minus the square root of 16. So x equals plus or minus 4. All right, so we're going to check both of those values. So let's check x equals positive 4 first. So that's 3 raised to the 4 squared power equals 3 to the 16. Well, we know that that's 16, so that's 3 to 16 equals to 3 to 16, so that's checked. Okay, so now let's check x equals negative 4. So then that's 3 raised to the negative 4 squared equals 3 to the 16. Well, that's again 16, so those check. So that bell tells us we need to move on to example 2. So let's move on to example 2. All right. So one change also is that this says 3 on your paper, but if you would change it to a 4, please. So now they have the same base. Okay. All right. So in example 2, we're seeing that we're adding. So we know that we multiply here. So that becomes log base 4 of x minus 1 times 3x minus 1 equal to 2. And I'm going to draw a horizontal line here just to save space for checking. All right, so now here we know from our notes that this can be written as to go from a log to exponential. Well, that was inconvenient. Those bells. All right, that to go from a log to exponential, we can write this as 4 squared equals, here we're just going to go and distribute. So x times 3x is 3x squared. X times negative 1 is negative 1x. Negative 1 times 3 is negative 3x. Negative 1 times negative 1 is a positive 1. So now let's rewrite this with the x squared on the left. So that's 3x squared. Combined terms, so that's negative 4x plus 1 equals 4 squared is 16. Okay? So now we need to subtract 16 from both sides. So then that's 3x squared minus 4x minus 15 equals 0. All right, this doesn't appear to be factorable, so let's use the quadratic formula. So we use x equals negative 4 is a positive 4 plus or minus the square root of negative 4 squared minus 4 times 3 times negative 15 divided by 2 times 3 So that reduces to be x equals 4 plus or minus the square root of 196 divided by 6. So x equals 3 and x equals negative 5/3. All right, so now we're going to check. Let's check x equals 3 first. So log base 4 of 3 minus 1 plus log base 4 of 3 times 3 is 9. 9 minus 1 equals 2. Well, when you plug that into the calculator, we'll see that this equals 2. So 2 equals 2, so it checks. Okay, so now let's check x equals negative 5/3. So then that's log of 4 Now when we plug in negative 5/3 in for x and subtract 1, that's negative 8 divided by 3 plus log of 4 of, now when you put in negative 5/3, or 3 times negative 5/3 minus 1, you get 3 times negative 6, and that equals 2. So when you plug this into your calculator, so log and let's put in a calculator. And let me adjust the brightness here. So log base 4 of, over here so we can see. There we go. Log base 4 of negative 5 divided by 3 minus 1 plus log base 4 of 3 times negative 5 divided by 3 minus 1. You get a non-real calculation. So that means we know that this is an error. So we can say that x equals negative 5/3 is extraneous. All right, so now let's move on to example 3. All right, example 3. To solve, we can convert the log and exponential. To do that, we know that we can write this as 9 to the 5th power equals x squared. Well, 9 to the 5th power is 59,049 equal to x squared. We take the square root of both sides. So x equals plus or minus 243. All right, now let's check. So then let's check. X equals 243 first. So you have log base 9 of 243 squared equal to 5. Well, your result is 5 equals 5, so it checks. Now let's check x equals negative 243. So you have log base 9 of negative 243 squared equals 5. Your result is 5 equals 5, so it checks. All right, so now let's take a look at example 4. Same thing, we're going to convert the log into exponential so that we can write this as 4 to the third power equals x minus 1. Well, 4 cubed is 65 equals x minus 1. I'm sorry, 4 cubed is 64. So if you add 1 to both sides, you get 65 equals x. All right, so again, we'll check. So let's check x equals 65. So we have log base 4 of 65 minus 1 equals 3. Well, that checks so that the left side and right side are both 3. All right, let's take a look at example 5. Now, example 5 is kind of like example 1, but we need the bases to be the same. So we're going to go to the base of 2. And so we know we can write this as 2 squared gives us 4. And 2 cubed gives you 8. All right, so now the bases are the same. We know the exponents are equal, and we're going to distribute. So 2 times 3x minus 1 is 6x minus 2, and 3 times x plus 1 is 3x plus 3. We subtract 3x from both sides, so we get 3x minus 2 equals 3. And then we're going to add 2 divided by 3. We get x equals 5 divided by 3. All right, so then we're going to check. All right, so then that's 4 to the 3 times 5 thirds minus 1 equals 8 to the 5 thirds plus 1, which gives you a result of 256 equals 256, so it checks. All right, so now example 6. Now example 6, you're going to take the log of base 3 to both sides. So you have log base 3 of 3 to the 2x minus 1. Remember, we did this because this will become 1 here, and we're left with 2x minus 1. But what you do one side, you have to do the other. So we're going to do log base 3 of 20. So this becomes the power of 1, so you're left with 2x minus 1 equals log base 3 of 20. Now you add 1 divided by 2, so x equals log base 3 of 20 plus 1 divided by 2. So x equals 1.863. All right, so let's check. So then that's 3 to the 2 times 1.863 minus 1 equals 220. So this equals 19.982, which doesn't exactly equal 20, but remember we rounded. Since we rounded, we know that that's close enough to 20 so that we know it checks. All right, so now let's look at example 7. All right, so here we're going to convert a log to exponential form, so that's going to be 7 to the third power equals 5x plus 3. So then we're going to subtract 3 divided by 5, so we have 7 to the third power minus 3 divided by 5 equals x. So we get 68 equals x. And then let's check. All right, so we check 68. So we have log base 7 of 5 times 68 plus 3 equals 3. Well, this results of 3 equals 3, so it checks. All right, example 8. Now, even though they're on the same side, the base is the same, so we can say that these are equal. So we have 2x squared plus 3 equals 5x. Now, we need to move everything to the left side, so we're going to subtract 5x, so we get 2x squared minus 5x plus 3 equals 0. Now, to see if this is factorable, I would recommend just drawing a box. Now, we know first term, last term, so we know 2x, 1x. Now we need to find all the combinations of 3. So since the middle number is negative, they have to be both negative. So negative 1 times negative 3 is the only combination. Okay? So we try the combinations in here. So let's try minus 1 here, minus 3 here. And our goal is to get negative 5x. So 2x times negative 1 is negative 2x. Negative 3 times 1 is negative 3x. These combine to be negative 5x. So here are our factors. So this factor is 2x minus 3 times 1x minus 1 equal to 0. So we set them equal to 0. So 2x minus 3 equal to 0. 1x minus 1 equal to 0. So then x equals 3 divided by 2, and x equals 1. All right, so we're going to check. And let's check x equals 3 divided by 2 first. So when you substitute 3 divided by 2 into the left side and the right side, you get 1.125 and equal 1.125. So we can say that this checks. So let's check x equals 1. So we plug in 1, and we get 0.898 equivalent to 0.898. Since the left side and right side equal, it's checked. All right, so now let's move on to example 9. All right, so example 9, we need to take the log base 5 of both sides. So that's log base 5 of 5x. We did that so that these will become 1 and we'll left x, but what you do to one side, you have to do to the other, so then that's log base 5 of 50. So then this becomes the power of 1, so x equals, and then the log base 5 of 50 equals 2 points. Well, I can't just show the steps. So log base 5 of 50, which equals 2.431. So x equals 2.431. All right, so now let's check. So then that's 5. Add another line here. 5 to the 2.431 go to 50. Well, 5 raised to the 2.431 is 50.026. Since we know we rounded, it's close enough to 50 to say that this is checked. All right, example 10. Now, since we're subtracting, then we know we do division. Since there's no base, we assume it's 10. So we have log base 10 of 3x plus 1 divided by 4 equals 2. Now we can convert this to exponential form, so we know that that's 10 squared equals 3x plus 1 divided by 4. We can now cross multiply. 10 squared times 4 is 400 equals 3x plus 1. We subtract 1 from both sides, divide by 3. We get 133 equals x. Okay, now we check. So when we substitute 133 in, so that's log base 10 of 3 times 133 plus 1 minus log 10 of 4 equals 2. We see that we get 2 equals 2, so it checks. All right, so with that, if you understood all the examples, then start working on an assignment. If you didn't, just know that we can go over examples and the assignment in class. So with that, have a wonderful Wildcat day.